Properties and operations. Here is where we're going to do some reviewing, and I think it was either you guys or algebra, where we talked about the commutative property. Okay. Commutative property, there's a big box on page 63 where there are commutative properties for both addition and multiplication. Any idea, can someone volunteer what each of them maybe says? Essentially, they're one and the same, the multiplication and the addition, but Alex, what do they mean? Commutative property of addition, commutative property of multiplication. Pick one, take them both, whatever you want. Yeah. Okay, so they give the example like a plus b is equal to b plus a. When we're adding two numbers together, just two, it doesn't matter what order we take them, we should still end up with the same sum. How about for multiplication? Same kind of thing. A times b is equal to b times a. If you're multiplying two factors, it doesn't matter which order you take them. It still works out to be the same. Any questions on commutative property? When might you use commutative property? Algebra, we used it yesterday fairly often, but yeah. Not necessarily order of operation, because we're really, Alex, we're just focusing on adding two numbers. We're not talking about like adding two numbers and then multiplying and then dividing and doing a bunch of other stuff. Just those two numbers up there. When might you want to use it? When might it be beneficial to you? Because this is a property. This is something that can be used as a tool by you to help you out with your work. Since it's up to you, it's pretty much a personal preference. Maybe you like the way certain numbers look. You know, instead of saying 8 plus 4, maybe you have a better understanding when you see 4 plus 8. Not like those are difficult numbers to add together. But where else it comes in handy is if we had like a negative 4 plus a 7. If I wanted to use the commutative property, how could I rearrange things there so maybe it says something a little more clear? Yeah? Let's just say that. I mean, you're right, essentially, 7 plus a negative 4, but essentially it'd be a 7 minus 4. So the tricky part there is where we say it's the commutative property of addition, and we end up subtracting through it all. But that's kind of what the nature of it is anyway when we start to work with integers and positives and negatives. Multiplication, same kind of deal. 4 times 9 is equal to 9 times 4. You work with positives, you work with negatives. Sometimes you work with decimals, and you'd have like a 4 times 12.6. Maybe you see it better as 12.6 times 4, and then you set it up as such. Just knowing that you have some flexibility with the order sometimes makes a big difference. The next, anything else on commutative before we close the book on the commutative? Yeah? Right, that's a decimal in that case, right. Now, the associative property also deals with addition and also deals with multiplication. Associative property really isn't all that different from the commutative. the major difference is that you're using more than two. Usually they say it doesn't matter how it's grouped. So if you have to group something, it's a pretty good indication you're using more than two. So, like for example, if you decide to group A plus B, then add C to it, it'd be the same as grouping a B plus C. And the grouping, in parentheses, will give you the indication that that part would be done in what order? Right, so that would tell me that I'm going to do that part first. So just for argument's sake, if we had 4 plus 2 plus 3, that would be equal to, again, a matter of personal preference. Sometimes certain numbers go together better. So on either side, you're still going to end up with your 9. It just depends on what looks better to you. Sometimes it works easier when you're speaking of putting like decimals together. Sometimes that makes things a little bit easier to justify. So if you had a problem like this, you may not want to take the 16 and the 21 first. How might you want to group it? Well, it might be easier to do it in your head. Key? Yeah, maybe I would say, you know what? That 16 and 14, they go well together. That's going to give me a 30. 30 plus a 21 would equal 51. Yeah. Well, it's more of an understanding of what it is. They may give you a problem and then they'll say, solve. And then you may see something like this where you say, okay, where am I going to go next? What's going to be most beneficial to me? And just knowing that you can do the 16 and the 14 before is using the associative property. These are tools. These are to be used by you to help you understand the problems better. You know, do them in your head easier. So multiplication would be the same thing. If you had an A times B and multiply it by C, same kind of deal. If you have just multiplication, you could take that in any order that you prefer. Yes? So let's, we'll throw a couple of these problems up here, and then I'm going to have you solve, and then we'll just kind of talk about maybe a strategy that you used. That's a 7. Okay, give those a. Try to solve those as best you can. Great. How many others of you did paired up the 17 with the 13 and then added the 36 to that? So Chris, then 17 and the 13 was what? 30 plus the 36? 66. Very good. Okay. You know, not oftentimes does math kind of work in your favor, or at least you don't think it works in your favor all that much. When you get opportunities like this, when you get tools to use that say, hey, you know what? You can adjust the numbers to your advantage to where you can see them better. Like the next one. Yeah. You did 3 times 5. Anyone do anything different? It's not wrong, but I don't know if you made the most of your opportunity there. So Alex, if we do 8 times 5 first, what do we get? 40. Now, if I look at that 40 times the negative 3, I could say 4 times 3 is 12 with the 0 and make sure to make it negative. We can make that connection. Did you still get negative 120? Yeah. But you know what I mean? Like, maybe for you, I can't tell. I mean, maybe for you that worked better. Maybe you know your 15 times 8 like that. Yes? Yeah, great. That's awesome. Not me. Easier for me to just do 40 times 3. Okay? So, just explore, play around a little bit. And then how about the last one? The last one. Go ahead, Alex. What did you do? Awesome. 3.4 plus 7.6. Then you'll add the 9.7 to that after. And then when you add the 3 and the 7, you get 10. And then you add the 0.4 and the 0.6, you get another whole. So what's in the parentheses? What do you get when you do the 3.4? See, if you do the whole number 3 plus the whole number 7, you get 10. And then the 0.4 and the 0.6 gives you another whole, which gives you 11. And then plus the 9. 11 plus 9 is 20. Be 20.7. Okay, so I mean, you may still have to do some writing, especially here, but most of the work was done where? On paper? In our heads. Okay, so if we can set it up in a way that makes it easier for us to do in our head, that's the whole point. That's the whole point, making things easier for ourselves. Turn to page 60. Well, one more thing. Bottom of 64, an easy one. Another property. It's really easy. The identity property. Your identity. If someone says they want to see your ID, what is that? Yeah. Who you are. You usually pull out your driver's license, or I don't know what you guys pull out if you got some of those ID cards you got from the picture people when they took your picture at school. But your ID has what on it? Your picture, right? Maybe your address, your hair color, your height, weight, at least your driver's license does. Did you? No, my kids have one of those little cards. Oh, me to wear around the hallways? Yeah. Give me a break. There's nobody here. That's what I was thinking. So if I have the letter A, and I want that A to stay exactly the same, and what am I going to add to it to keep it exactly the same? Chris? Yeah. I made no changes to it. Stays the same. After. I mean, we're going to take a look here. If I want my identity to stay the same with the multiplication, is it going to be 0 after 8 times what? 1. So for the addition, I use the 0. For the multiplication, I use the 1. So the 0 property is what? 0 property applies to the multiplication. It says anytime you take a number and you multiply it by 0, you're going to get 0. That's the 0 property. So it's a little bit different. Okay? All right? All right, buckwheat. So page 66. She said ote, right? Isn't that buckwheat? Number 3, mental math. Says evaluate the expression, justify each of your steps. Okay, parentheses 26 plus 18, and then they add 34 to that. Would you do it any differently